Well, thanks very much for inviting me. It's a great pleasure to be here. I don't come enough to Portland, and it's not raining. As Mary said, I had to give the Woytinsky lecture a couple weeks ago in Michigan, and I was struggling with trying to decide what I wanted to come up with a kind of a general theme for that lecture, and a question that a lot of students and other faculty and colleagues and people ask me a lot is how I see research evolving especially in the kind of labor, public economics, development economics area. At Berkeley, those three topics are sort of closely related, so most people, I kind of think of that, as well as industrial organization, as an empirical micro. And so this is a lecture with my thoughts. It's not really any conclusions, but my thoughts on a kind of a question that comes up a lot, which is when you're thinking about empirical projects or a project in empirical micro, what's the appropriate role of a theoretical model? And I'm going to try and make the argument that we can think usefully about two ways of classifying research, and the way that you come up with ideas, the way that you write the paper, the way that you really sell the paper. And one of those I'm going to call a model-based approach, and one I'm going to call a design-based approach. And I'm going to try and go through the following things. I'm going to talk about a bunch of background issues that always come up in sort of methodological discussions in economics. One is the role of models in establishing causality. And we'll start off with that because that's I'm not very well, as our president said, it might be well above my pay grade. But that's an issue or a topic that is something that some people have weighed in on very strongly. And if you have a strong opinion about that issue, then of course the answer to how to do empirical research is very clear. But I'm going to try and argue that in fact there's a divergence and quite a wide range of possibilities there. I'm going to talk about the role of working models in social sciences and economics in particular. And what I mean by working model and classification of types of models. I'm going to talk about alternative meanings of the word identification. So these are sort of three, what do you mean by causality, what do you mean by a model, what do you mean by identification, which are sort of three preliminary topics. Then I'm going to kind of do what I consider sort of a brief history of the area. And it's going to be brief in that it's going to pick up about the time that I became an undergraduate and go to today. Not that there wasn't interesting things going on, and I will go back a little further than that. But that's a very long time ago anyway. Then I'm going to talk about what this history is going to lead us to sort of an evolution, ebb and flow in the role of models in empirical research in this area, set of areas. And I'm going to talk about what I think the takeaway from the kind of latest resurgence of work in the design-based tradition. And then I'm going to talk about what I see as the sources of conflict between these two. And there's I would say, fairly evident uncertainty / conflict between different sides of the debate, different approaches here. And I'll try and underscore what I see as the major reasons for that uncertainty / debate. And then talk a little bit about where I see things going and what are some of the things that are leading the next wave of developments in this area. Okay, so by way of background issues, I'm going to start off with causality. And I should say, let me emphasize, I can talk really fast. And I will talk fairly quickly, but you should by all means stick up your hand, and I'll be glad to spend as much time as we need to discuss the issues, and then I'll just talk faster. So don't feel like you're going to slow down progress by asking a question. If there's something comes up or a thought or whatever, by all means go ahead. So models and causality. Basically, my view is that one of the main goals of economic research, especially in microeconomics, empirical micro, is to draw causal inferences. So we're all familiar with the perplexing inability of most people to distinguish causality from correlation. And we can easily be fooled ourselves. Many of us firmly believe that some particular drug is useful for us, and then, probably at some point you're going to find out that actually that drug doesn't do anything. Purely a placebo effect, which could be a causal channel. So there's one view, which I'm going to associate most strongly and most recently with Jim Hackman. Jim has a paper, it's a NBR working paper, and I believe it's published someplace, but the NBR paper is pretty accessible, in which he tries to make the case that causality is inherently a model-based concept. In other words, that you can't really speak about causality in the absence of a theoretical framework that says that it makes sense to express the statement that X causes Y. And that's a fairly, I would say, polar view. The opposite view is a view that I associate with Paul Holland. Paul Holland is a statistician, and he has a phrase which I must admit I'm a little bit more sympathetic to. His phrase is no causality without manipulation. And that is the idea that causality is inherently a design-based idea. That you can't talk about causality unless you can imagine a research design where you can manipulate X and see what happens to Y. And so you can sort of see the two kind of views here. If you take the Holland view, astronomy is out. because there's not really any causal manipulation of planets. If you take the design, if you take the Heckman view, then most of medicine is out. Because actually today, people still don't really understand why most things work. Aspirin, for instance, no one really understands why it works. And we're constantly discovering, even 100 and some years after the Bayer company kind of dug it out of Russian folklore, that you could use aspirin, we're constantly discovering new uses for aspirin. Okay, so now, everybody knows you're supposed to take a baby aspirin when you get to my age, so you don't have, your blood kind of stays thin, but there's all kinds of new products and new ideas about that. And there's virtually no theoretical framework. In fact, the best story about this I know is the research that was done in the 90s on trying to see whether plants and species from tropical regions were good for curing things. And the major pharma companies spent a lot of money going through South America and Africa asking people about their folk cures, and then taking the plants and things that they were identifying and testing them out in the lab. So that was a pure data mining. And in that realm, most recently, there's a whole new branch of statistics, the data mining, or machine learning, they call it. If you want to see Jim Heckman go crazy, just mention the word machine learning. Machine learning is entirely a data mining process. It's a kind of a slightly disciplined data mining process where, and that is basically what's driving most of what you see on the internet. A huge amount of decision making is going on the internet, auctions at Google to auction off the right to show you an ad in a certain order and so on. A lot of that is done with machine learning. So those are the two views. And it seems like there's not much in between those two views, but I was doing some research on this topic, and I found out that the godfather of econometrics, Havelmo, this is the guy. This is the lead article in Econometrica, Volume 1, Number 1. This is like the mother lode, kind of the mother church article. And this is the article which most people attribute to finally getting straight how to estimate demand and supply curves when you've got kind of an instrument on each side. Surprisingly, although we think of ourselves as incredibly clever and smart people, economists, blah, 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 if you want to read some depressing stupidity, just read papers written in the 20s and 30s on estimating demand functions. Even really smart people who had great careers, were completely confused, had no idea what they were doing. And so the idea that you would put together a demand curve and a supply curve, think of the reduced form, and you need something that's just one and something that's just the other, and that was completely foreign. Completely confused. Havelmo kind of laid it out. And in that same article, Havelmo was actually more of a statistician. He was trained in part by Jerzy Neyman, the guy who first laid out how to do clustered sampling. And was very influential in the design of the first current population survey. Anyway, in that he says the following. A theoretical model will have an economic meaning only when associated with the design of actual experiments that describes and indicates how to measure a system of true variables that are identified with the corresponding variables in the theory. Now, what's remarkable about that is two things. One thing is the use of the word design of experiments. I have to say that when I read that, up until about the mid-1990s, no one in economics used the word research design. I happen to know that because in 1992, my colleague at the time, Alan Kruger, had some extra research funds and decided for fun to subscribe to the New England Journal of Medicine. And the New England Journal of Medicine, at 1992, Economist was reading, every article starts at the beginning and it says, hypothesis research design. And Alan and I were looking and saying, what the hell is this research design thing? That's not a phrase that economists used to use. Now, it is widely used in this so-called literature on design and experiments, how to lay out fertilizer plots, Latin squares, and all that kind of stuff. And what Halamo was pointing out was that basically, in his view, which I think I would like to stick with as a possible sort of compromise, is that you need kind of a theoretical model and a design. And then you might be getting somewhere. And he doesn't actually say, how deep this theory has to be. Can it be something as simple as, higher prices cause me to buy less, more income causes me to buy more? Do I need to specify a utility function, or can I just say that? So we're going to talk about that in some detail. So this is my kind of resolution of the two sides of causality, which is let's stick with Halfman. Now, the good part is that that's going to shut up everybody for 2 minutes while I move to the next slide. Okay, models. My argument is that there's no papers in economics that don't have models. And even papers that have no equations have models. And I'm going to call that a working model, to sort of step back just a tiny bit from a specific set of equations or Greek letters or tools that you might use for trying to solve a model, and say that inevitably in a paper you're going to have a framework that specifies a bunch of things that are actually incredibly important. So you're going to specify who the agents are. That's a new word, by the way. We didn't used to call people agents. In the 60s, we thought that was like James Bond. Somehow James Bond became the main person in all economics. But then what really made agent special for me is later movies. Anyway, agent decision variables that they're trying to decide over in the institutional setting, and working models implicitly at least specify a whole list of things that kind of narrow your focus. So, whose behavior are you modeling? So if I start my seminar and say I'm going to model female labor supply, then everybody knows what I'm talking about, roughly speaking. They know that I'm going to be modeling possibly hours of work per week, possibly weeks per year, maybe intertemporal. I'm probably going to be focusing on women as individual decision makers when I write down female labor supply. I'm probably going to be assuming that that female decision maker takes her partner's income as given. Which, if I said I was studying family labor supply, everybody would know that's not what I'm doing. If I said I was studying family labor supply, we know that I'm actually going to try and model the joint labor supply of both parties, and I'm not going to take the income of one party or the other as given, but think of them as simultaneously determined with some other exogenous variables. So we're very good at that in economics, and outsiders, sociologists or psychologists, are often impressed by the economy of our language. We think of ourselves as not that impressive with our language most of the time. But we are pretty good at saying, I'm studying consumer demand issue, I'm studying particular antitrust question, and instantly most people have a pretty good idea of at least this set of questions. Now, when you say, so the first thing is whose behavior, what are the constraints, what are the exogenous price variables, then there gets to be more and more detail. For example, what variables are known or observed, and which ones are sort of going to be assumed to be unknown to the. This is a phrase we use that is very mysterious. My wife sometimes looks at every time we're kind of having some problem communicating, she'll say, "Is that one of those things that's known to the agent and not to the econometrician?" Now, you see, that's a remarkable piece of economy in a way, because we've sort of subsumed in that, okay, the agents know what they're doing, we don't, that's the unobservable that's going to drive some outcomes that we can't explain. Very useful in a spousal discussion. What time horizon, level of aggregation, and I would say that a successful working model causes a suspension of disbelief. And you can see that in a seminar. If a person is doing a good job with their working model, and it doesn't have to be equations, it can be that they're just very persuasive talkers, then everybody just sits silently for at least 25 minutes. If they're doing a bad job, people start throwing up questions right away. They say, well, what about, this unobserved variable? Or what about this other time horizon? Or what about these other constraints? Or I don't like your constraints. I want my constraints. So the kind of force of personality combined with the brilliance of the presentation, so on, often will be more important here than any particular other aesthetic criteria.
I'm sorry to point out you already have a question.
Oh, yeah.
So constraints here is vague, and maybe you're using it as a term of art which you expect me to understand, but time horizon, level of aggregation, these are also constraints. So how are you distinguishing line 5 from line 2? What are you intending to include in line 2?
I'm going to leave it vague, actually. I don't.
Okay.
Yeah, I think it's exactly that. For example, in some communities, you're not allowed to use the C word, credit constraints. Right. So in other places, it's okay to talk about credit constraints.
Okay.
You can, and so in some seminars, you're sort of supposed to assume that everybody has access to a linear budget constraint and borrow lend freely. In other contexts or other institutional groups or whatever, you're allowed to open that up. So I think any given paper will try and specify that, and sometimes there'll be a debate about it, sometimes there won't.
Okay.
Yeah.
But it sounds then like you mean right there constraints of the agents, not the study, whereas line 5 is constraints of the study, not the agents. Is that the distinction you're drawing?
Yeah, or in a way, it's like, what am I trying to model?
Okay.
Right. I think that's what I'm doing. What am I trying to describe?
Okay.
So despite I think relatively speaking, economists are pretty good at having a useful discussion about these issues. It's important to understand that what some model says is the exogenous variables, another model says are the endogenous variables, and that you can think about a lot of research programs as attempts to try to endogenize what appear to be constraints or appear to be choice variable, exogenous variables. So for example, the classic example of that, of course, is general equilibrium. In a partial equilibrium model, the supply side is exogenous when you're modeling the demand side, and then in a more general equilibrium model, you might have to worry about, well, some of the same things that are shifting demand, causing prices to go up, ultimately will cause supply to expand and will be confounding supply and demand. Or you could even go beyond that in general equilibrium. This market could be affecting other markets and the whole aggregate economy. The unobserved tastes or abilities that are often in some models are probably among the most interesting things to try and study, and some of the most interesting new work by my colleagues, for example. George Akerlof has been interested in this line of research for basically much of his career. So how do people decide that there's somebody that likes to drive a Japanese car versus an American car, or that likes to drink wine versus beer, or that wants to have a 3,000 square foot house in the suburbs versus a 1,500 square foot apartment in Manhattan. So those things are driven by potentially peer effects, by identity choices, by all kinds of different social phenomenon. And at one time, I think those would have been thought to be beyond the pale in economics, and now they're pretty much a part of what everybody's talking about. With all of that, there's a wide debate about what's a legitimate working model, and I'm going to come back to this a couple of times in the talk, but basically it's important as a labor economist or as somebody working in empirical micro and doing kind of very rudimentary modeling, which is kind of I usually do, that the trend outside of micro is to very complicated models that incorporate three key ingredients: dynamics, imperfect information, and general equilibrium. And if you're trying to remember, just think of what they call the standard model in macro these days is DSGE: dynamic, stochastic, general equilibrium. So the basic working model in almost all of macro, with the possible exception of Berkeley and a few other places, is a DSGE model. So they don't really get going. There's not even any discussion about static, perfect information, partial equilibrium, which is, of course, the main thing that most labor economists use all the time. So we're kind of like, we're short in all three dimensions. And that's pretty important when you're trying to, say, bring in a job candidate, and the job candidate is giving a talk, and all the macroeconomists say, well, that model doesn't have any general equilibrium, it's got perfect foresight, and actually it's only a one-period model. How can that possibly be relevant? Okay, in the thinking about this, I decided that I think it's kind of useful to think of three classes of models, and they sort of represent different stages of development of economic thought in the last 40 years. So when I went to graduate school, the standard way that people wrote papers was to have something like this. There would be a fairly elegant theory, like consumer demand theory, and it would say that under general circumstances, under kind of everything we all know from first year micro, there's going to be a demand function which relates the quantities purchased by a given agent to the prices and income, and possibly some preference terms, which we're not going to say too much about. And theory says that that functional relation has some restrictions. So that's the Slutsky symmetry and negative semi-definiteness. So the substitution term has to be negative or zero. And that is the content of the theory. And that was, if you read Paul Samuelson's Foundations, which if you want to be intimidated, you have to remember that was his master's thesis. Samuelson worked that out and said, okay, that's the empirical content of demand theory. Slutsky symmetry and NSD. Negative semi-definiteness. So that is what we should be testing. If we really wanted to say economics is a science, science had falsifiable predictions, this kind of Popperian idea. And so that's what we do. Now, the model, of course, doesn't tell you how any given person behaves, and so when you go to do empirical research on testing that, you have to sort of tack on an error. And in the 60s and 70s, and even in the 50s, it was kind of common, for instance, the Coles Foundation monograph, which is the one that laid out Limmel and the maximum likelihood approach to simultaneous equations in the 50s. They basically thought of these as measurement errors and other things. They didn't exactly specify where these errors were coming from. And Hal White, in 1980, provided us with a lot of cover, where he said, okay, we could think about you trying to estimate a model like this. You approximate it with this kind of a model, and there's an error term here, which is an approximation error, as well as errors of measurement and so on. And so he kind of expanded the set of errors to include approximation errors that potentially can be understood and have certain statistical properties and that we have to be concerned about. And that's where a lot of concern about, say, heteroscedasticity emerges. The archetype of this would be the consumer demand and labor supply models of the 1950s through the 1970s. So my former colleague Angus Deaton has a Frisch Prize winning article in Econometrica trying to estimate whether consumer demand functions fit to the UK data for a certain time period satisfy the Slutsky conditions or not. And there's an ongoing series of papers from about mid-70s on saying, well, what about this and this and this complication to that story? So that's kind of an ongoing paradigm. But all those papers kind of start with an explicit model, but then go to an approximating thing when you get to the empirical work. Okay, so that's what I think. Now, in 1968 or 69, Dan McFadden solved a problem that had been kind of lurking in the background in microeconomics for a long time. At that time, people were thinking about trying to choose between discrete items, and McFadden figured out how to write down a specification of preferences that gave rise to the multinomial logic. So he did the inversion. And we all know how to do that nowadays. You say, well, I'm going to have a preference equation with an extreme value type 1 error, and Dan showed if you do that, and you look at all your equations, you're going to have what turns out to be a multinomial logic. And that was a major accomplishment. And what's interesting about that is it's a specification, not just of the x beta part of the equation, but it also is an explicit specification of the random part. So it's what I call an explicit exact. And it's exact in the sense that I am making a statement for all time that the distribution of unobservable preferences is extreme value type 1. Okay? And when I do that, I can then get this explicit functional form. And in this deep literature on modeling and causality, that's what they call an all causes model. Because you're actually taking a stand on all causes. You're taking a stand on the stochastic part that's known by the agent, by the econometrician, my wife's favorite part, as well as the other part that we can measure. And the focus in this kind of work is on estimating both the model parameters and the distribution of unobservables. And there's a lot of reasons for that. Mostly this is preferred because it can be used to estimate out of sample and can be used to do welfare analysis. And we'll be talking, I'll come back and talk about that. And the archetype of that is the multinomial logit, and this is used every weekend. Probably 50,000 regressions are run with people having this in the back of their head. And this is now the third type of model, and this is the kind where if there was somebody in the audience who was especially a true believer in the second type, this is the kind where they might object to calling this a model. And this is the kind of model that appears in many of my papers, which is a narrative model. In other words, no model. So what's going on, for example, in a training program evaluation paper, where, what am I doing? Well, I'm trying to specify an equation that says, this is the earnings that people get in different states of the world, and I'm particularly interested in a comparison between this state and that state. And my model, quote unquote, is that if you participate in the training program, your earnings will be different than if you didn't, and other things equal. And so there's no precisely specified behavioral equation. There's a focus instead on this sort of structural outcome equation. And I put structural here because this is not what structural econometricians or structural economists these days would call structural, although this is structural in the sense of the Coles foundation. This is a two-stage least square system. This is the structural equation. And there's lots of archetypes of this. Non-market behavior, Steve Levitt's famous paper on police and crime, for instance, arguing that more police causes more crime, causes less crime. You can say, it's not a narrative. I know that well. But if you read Steve's paper, which I have done, he doesn't really elucidate. You can imagine a million causal channels why police have more policing might cause less crime. So it could be that people fear they're going to get caught more. It could be because people are criminals, but only if they see an opportunity. And so that's the sort of accidental theory of crime, which is pretty widespread in the criminology literature. And any one of those channels could work. This kind of analysis is unlike the previous models. You can measure a causal effect of an existing policy, but it's very difficult to extrapolate it. So, for example, in the active labor market policy, training program evaluations, you can say, okay, this training program seems to have worked. You can do that in an experimental setting, for example. But it doesn't really necessarily tell you much about other training programs because you're not really trying to say, well, the reasons why the effect came about was because of this set of parameters. I changed this person's preferences, I changed their human capital, I changed the perception employers have about the quality of the resume. All those things would be potential manipulables. And I did, for example, a study of the Mariel boat lift on the Miami labor market, which would be totally in that camp. That study shows that, kind of shows what happened when the Marielitos came to Miami, but it's very difficult to infer much about that from the general effect of immigration on the U.S. labor market for an infinite number of reasons. Okay, so the last background issue I want to talk about is identification. And identification means two different things to two different audiences. One is what I call econometric identification, and that is basically the question of, can I get the parameters I'm interested in from some characteristics of the data? And that's what an econometrician means by identification. Linear supply and demand models, the famous papers, this is working sort of figured out that there's something wrong with running a regression of price on quantity and calling that the demand curve. And then it took all the way to Havelmo to say, well, if you've got a demand curve and a supply curve, how do you interpret that? CS production functions, this is something that used to be known, not known so much anymore. If you have an aggregate economy, like the US, and if wages are different in different parts of the economy, then the US economy, even if everybody in the US has a CES production function, the aggregate production function is not CES. The CES production function does not aggregate. So that's a non-identification result, which Frank Fisher wrote a number of papers in a book on, basically, saying that this is a big problem, our basic model. Now, we've conveniently forgotten about that. And I advise you not to worry about this ever again. It's sort of like my colleague Pat Klein has sometimes in a computer program, we're working on a very complicated computer project recently, and I'll have a piece of thing that says, "There be dragons." This is the dragon side. Recent work has extended that inversion to multiple, more complicated situations. So the Imbens and Angus-Late framework, local average treatment effect framework, says, what are we learning, what are we identifying when we've got, say, a two-simple causal model, but we've got heterogeneity in the treatment effects, and not everybody is treated? Well, then we know we're kind of estimating the treatment effect for the treated group. And we can think of that as a local average treatment effect. And most recently, there's a whole literature developing in econometrics on partial identification, where you can't actually invert the empirical results back to a single value for a parameter. What you can identify is, say, a interval, and the set identification. The other meaning of identification is this is what I call the identification police. Okay, so if you send a paper, you're probably all familiar with this. If you send a paper to a journal, and you're trying to claim that you've got some result, the identification police are the people who say, no, you haven't shown anything. Sorry. There's 50 other explanations. Your instruments suck. Your variables are mismeasured. There's all these confounding influences, and I reject your paper. Okay, so now the gold standard by this kind of identification is a randomized trial, RCT, randomized controlled trial. But even with an RCT, there's issues of identification in the sense that people will say, well, did randomization work? Was there partial compliance, sample attrition? And actually, the clearest way to understand the late is in an RCT context with partial compliance, where then your experiment is revealing a causal effect, but only for the subgroup of the treatment group who actually comply. In observational data context, there's lots of things that we've developed over the years to try and check that we've got some kind of consistency. So over-identification testing is something like you've got multiple instruments, you're trying to see whether you're getting the same estimate from when you use different instruments. Nowadays, people will look at other things they call falsification tests, or other types of tests, like if you do an event study for a difference in differences type analysis, you'll often be asked by a referee to show that the two groups moved together in parallel before the intervention, and then they departed, and then they stayed departed. And that's kind of an informal test that the counterfactual that you're using, which is that the treatment group and the control group would have stayed in parallel in the absence of your treatment, is actually true. And I think it's important to understand that this doesn't really prove anything. Remember, what you can really do from a purely scientific view is reject null. And this is sort of trying to say, well, I can prove that you should accept the alternative. And of course you can't do that. So you can never, even in a randomized trial, you can never really say for sure that you do anything other than reject the null, at least in a standard framework. You could, if you're a Bayesian, you could say you move the prime, for example. That's why I say this is more art than science. Okay, brief history.
Could you just say a little bit, because the previous, that's very important, I think, right, nowadays. Could you say just a little bit more, because it seems like there's a lot of folks that are really reacting quite strongly to this. There was a review in JEL recently by Martin Rivalian,
yeah,
of the poor economics, some strong stuff there. What's kind of
RCTs are not the way to go.
Not that they're not the way to go, but that it's being pushed too hard.
I'm going to come back to that.
Okay.
I think the subtext. I think Angus Deaton, my friend actually, and I have massive disagreements, and he weighs twice as much as me, so I only get in a disagreement with him once in a while. But I would say, I'll come back to this in a second, but my impression is that actually the debate is not really about RCTs, it's about the questions you're studying. And they're using criticism of the RCTs as cover for, I don't like your questions. That's what I think the question is. So, but yeah, is that all right if I come back to that?
Absolutely.
Okay, yeah. Because this is still supposed to be the introduction.
Okay.
Okay, brief history. I'm going to have to go briefer. Before the 1970s, so this is the ice age of labor economics, there was a lot of econometric modeling, which was done mostly with macro modeling. So this is like the Brookings model and the Wharton model. There was all these models that were some of them had like 200-300 equations actually. Amazing pieces of work. And there was this one guy, if you want to laugh some night, there's a guy named T.C. Liu who wrote a couple of papers in the 1950s. This guy must have died angry. He wrote a whole bunch of papers saying, actually, these econometric models make no sense, and they're not identified. And no one paid any attention to him until, much later, but actually he was probably right. Dennis Harding wrote a really nice article in a book in 1964 talking about wage determination models. So this is completely hopeless. We're not getting anywhere. In labor economics, which is my field, Greg Lewis was the grandfather of labor economics, serious labor economics. The person that, the only person that my advisor is Orly Eschenthal. The only person that Orly scares the shit out of Orly was Greg Lewis. The only person he actually took seriously, because this guy he was such a careful person. He's the advisor of Gary Becker, Sherwin Rosen, Bob Lucas, virtually everybody of any repute from Chicago. And he spent the decade up to the 70s studying the effect of unions on wages. In the late 1960s was the first large-scale microdata available. So the 60 census comes out in microdata form in 66, 67. So that's the very first human capital equations fit with microdata by economists. Is in the JPE in 67 or 68. The first labor supply equations. The very beginning of the negative income tax experiments get started in the 60s, which was, again, microdata. The PSID gets started with the Survey of Economic Opportunity, started in 1966, 67. In the 70s, we've got the microdata, computers are getting better. At the same time, McFadden develops the Logit model. If you read the history, his thing in his Nobel lecture, you'll find out that he actually, the graduate student he was working with at the time was interested in trying to predict what would happen to demand for car transit at the open to BART, and they were using the Logit model. With all its strengths and weaknesses, they tried to use it to predict what would happen to traffic demand across the Bay Bridge when the BART was open, with no data. Okay, so that's the great thing about the Logit model. With the Logit model, you can predict the demand for products that don't exist. Just think about that. That's the kind of thing that on the one hand you say, isn't economics great? On the other hand you say, well, why does anybody believe these economists? And that's exactly what's often required in antitrust analysis. That's why you need a flow model, because you're asked for a counterfactual that's so far out of the sample that you're kind of like in that situation. Okay, labor economics, we have the labor supply studies get started. This is kind of a sad story. I'm not going to go into this, but labor supply by labor economists is kind of a history of zeros. The negative income tax data came in. It was mostly analyzed in a sort of semi-structural sense. There were these microeconometric studies of the union wage premium. So Lewis had spent most of his life looking at aggregated data. These are the first sort of wage equations, micro wage equations, and the Mincer at this time. And then Heckman introduces a sample selection model to sort of say, well, some of these observational designs are not going to work because we've got to select the sample. In the 1980s, we have a crisis. I get to graduate school just before this, and by the time I got to graduate school, it was kind of a disaster, actually. So we would study the papers, and no one would read the empirical section. You would study the first half of the paper, and when you got to the results section, you stopped reading, because no one took it seriously, and that's honest to God truth. It wasn't worth reading the empirical sections because everybody knew it was kind of a joke. Lucas wrote this famous critique article arguing that the predictions and analysis from the macro modeling was just not worth reading. It was all screwed up. David Henry, in his inaugural lecture as a professor of econometrics at the LSE, has an article called Alchemy or Science, in which he was criticizing econometric practice and saying it was mostly alchemy, very little science. And Leamer wrote a series of articles ending with the book, basically talking about the specification searching that was going on to get rise to t statistics that were above 2. So basically, everybody thought that the results were pretty bad. that this sort of previous generations of econometric work was bad. There was a sort of systematic attempt by 3 guys to take all the papers that were published in 1 year of the Journal of Money, Credit, and Banking. And they went back to the authors, asked for their data, and tried to reproduce all the empirical papers. And it was a complete zero. They were able to reproduce 0. Now they were able to get a few of them this is in the AER, it's pretty depressing. They were able to reproduce a couple of them fairly closely. A few authors said that the dog ate my data, that kind of thing. And a lot of the papers, it turned out they were just massive mistakes. And no one caught it, no one took it seriously. Now it wasn't, this is a field journal, it's a fairly respected field journal, but it's not the top journal, but it was, this whole thing was pretty disturbing. Around the same time, a little bit after that, is Bob Lalonde's thesis. Bob was my first thesis student with Orley at Princeton. And Bob did this exercise where he took a true experiment and tried to estimate the effect of the program that he was studying. It was a training program. If he didn't use the real control group, but used an artificial control group and econometric methodology. And he showed that that was a bit tough because different econometric methods, different alternative sampling techniques, all of which seemed kind of plausible, gave very different results. And it's exactly what everybody was concerned about, that it was too hard to tell whether you were on the right track or not if you didn't have the true experiment. And then kind of the thing that really nailed it for some of us, and although this is very inside labor economics talk, Greg Lewis wrote his last book in 1986. And this book was an attempt to sort of synthesize up to that point this huge literature, which is now long forgotten, trying to estimate the effect of unions on wages. And there was kind of universally agreed that if you ran an OLS regression, you would find that unionized workers earn 10, 15, maybe 20% more than non-union workers, and there's some variation in that. And Greg was reviewing the next generation of research, which was the instrumental variables and Hackett type methods, to do that. And I know a lot about this because when I was a grad student, he was visiting Princeton and hired me to try and reproduce some of the studies. It was kind of sad. Many of the studies, you couldn't actually tell what the instruments were. You couldn't tell what the sample exactly was, what the sample size was, what the exclusion restrictions were, and so on. And so what Greg at the end ended up dismissing those and said, okay, I was going to write a chapter on these, but I decided they're all trash. Now, these were all written by his students and by very respected people, the applied econometricians. And so this was a major slap in the face for people who were paying attention. So what happens in the 80s and 90s is what I would call the emergence of the design-based approach. So this is the first few papers that I was aware of. Josh Angrist wrote a paper using the draft lottery number that people got in the Vietnam draft as an instrument for military service to try and see what's the causal effect of military service. Now, I have to say that the idea for that came from a bunch of epidemiologists at UCSF who'd used it to look at the same idea to look at mental health. And Orley had seen the article and said to a bunch of graduate students who were standing around in the IR section at the time, here's a good idea. And Josh said, yeah, that's a good idea, let's go. Then there's the quarter of birth instruments. This was Angerst and Kruger. They were looking at military service patterns, and they noticed that there was this very strange pattern of schooling in the quarter of birth. They were trying to estimate the effect of World War II service, actually. But they got onto the quarter of birth as a source of variation in education. I wrote a couple of papers using this kind of quasi-experimental or training program technique, the variable boat lift, and some of these minimum wage studies are like that. And then the regression discontinuity idea, which I think has probably been extremely influential. Josh kind of rediscovered that, pulled up an idea that had been out there and invented really by educational psychologists. David Lee kind of developed a very good framework for thinking about what's wrong with an RD, when can it fail, is it falsifiable, and so on. And I would say that this sort of a design-based approach has had a lot of influence in empirical micro. If you look at the number of papers written in the kind of, those techniques have now been absorbed in public finance and economic history and development, in lots of other, even in macro, people do these things every once in a while. And at the same time, there's an explosion in lab-based and field-based experiments, sort of directly trying to address causality in this design-based framework. Okay. So what are the insights from that? I would say we've learned about counterfactuals. So no one used the word counterfactuals except when they were talking about law cases in the 70s and 80s, and now everybody talks about counterfactuals all the time. It's like research design, it's one of those new words. And there's a pretty strong tendency for equating identification and research design. So if you're talking, this is the second meaning of identification, if you're talking to a bunch of labor economists, they'll say, what's your identification strategy? I.e., what's your research design? That's, everybody understands what we're talking about. I think we've made some progress there. We, I think, largely believe that randomization would be a gold standard for asserting causality, and everything else can be thought of as attempts to get what you could do if you could run a perfect experiment. And so I think we kind of understand that much better than we did from a variety of, many people have contributed to that. We've also made some progress on thinking more carefully about what's credible and what's not credible, and so it's a lot harder to publish a crappy paper than it used to be. Lucky for me, I'm so old I don't have to publish so many anymore. So we've got, if you do an RCT, nowadays you have to show that the treatment group and control group are the same on the pre-treatment characteristics. You're just not allowed to say, here's the treatment. You have to show that randomization worked, quote unquote. If you don't, if you do something else, you're often asked by the identification police to have lots and lots of robustness checks, falsification checks, whatever they call it. You do treatments before comparison, you've got falsification, you've got multi-way differencing, you've got all kinds of different techniques that have kind of become part of the toolkit. Replicability is now something that people talk about and are worried about. And apart from the QJE, all the top journals now require authors to deposit the stuff with their programs and data. And I think that's good. I would say, for any graduate students in the room, I do not recommend replication as a enterprise unless you've got a very thick skin. Because I can tell you that people get really ticked off if you replicate their results and find an error. They just don't like it. And it gets them ticked off forever. So I would say, be very careful about replicating. It has to be worth it. I think it's really good scientifically, and it's good for the profession that we find out what results hold up and so on, but we haven't really overcome the problem that if you replicate someone's results and you show an error, they hate you forever. Okay. Two other things that I take away from this literature. Now these are more my own personal takeaways. One is that I think the standard channels in economic models often explain very little. The R-squared for those models is pretty small. There's a bunch of reasons for that, potential reasons. One is that the true elasticities are small. In other words, labor supply elasticities really are small. It isn't really the case that people really move around a lot when we wiggle their exogenous variables. Another possibility are these next two things I mentioned, that either there's some difference between the short and the long run, and these research designs are often better at finding a short run effect than a long run effect. The design itself kind of falls apart in the long run. It's only good in the short run. So maybe that's one problem, or maybe institutions adapt. So for instance, I wrote a couple of papers on the UI system in Canada, unemployment insurance system. And my belief is that in Canada, for instance, eastern provinces of Canada, institutions evolved over many decades in such a way that communities, the fishing communities, effectively set up to maximize income from the unemployment insurance system. So it became a system where you could work for 10 weeks and then collect unemployment insurance for 40. And the way it worked in a lot of those communities is once you've done your 10 weeks, your job was to get out of there and let somebody else do the 10 weeks. It was not experience rated. You can imagine that that's a bit of a problem. There's another class of explanations, which is inattention, procrastination, and other sort of behavioral type economics explanations, which I think I'm going to talk about a bit more. I think are also potentially very important in some contexts. A second thing I think is that we as economists have to be thinking all the time that we don't know quite as much as we think we do. And a lot of times the things that we say very confidently must be true are in fact not true or don't hold up to empirical tests. Let's put it that way. So the example of that is minimum wage studies. I wrote a number of papers on that, and a number of people have written papers on following up on that. And in my view, a lot of those papers are pretty credible and show you can raise the minimum wage and you're not going to see massive losses in employment. You're going to see, on average, something much closer to zero. This was a pretty disturbing study. David Lee and John Denardo, two of my thesis PhD students, finally got a research design for answering Greg Lewis's question. So they got union election vote study, and he looked at narrow victories and narrow losses in certification elections for unions and said, okay, 5 years later, what's the effect on wages? We'll know that the ones that had a victory for the union certification election are more likely to unionize. What's the effect on wages? The answer is 0. No effect. So that really calls into question this sort of idea that there's a causal effect, at least in every sense, a causal effect of unionization on wages. Because you can unionize an establishment, you've got a very good counterfactual, which is the establishments which just narrowly lost, and you got nothing. And then this is my current favorite. I did a paper, a couple of years worth of papers trying to study the effect of using regression discontinuity techniques, trying to study the effect of Medicare eligibility. At 65, everybody becomes eligible for Medicare. So we go from a system where 20% of people don't have health insurance and another 20% have really poor quality health insurance to a situation where virtually everybody has good insurance. And I would have thought, in my naive Canadian way, that when we go to a system like that, after 65, we close up all the disparities. So we could sort of illustrate how universal program health insurance would actually close disparities. And in fact, most health care utilization disparities widen. So I like to say that the United States is the only country where a universal program can be disequalizing. But it's an example of how you've got to really think carefully about how the incentives of the different players in the market and how they've adapted to the different settings. And so what happens, of course, if you know much about this, is that when you get to be 65, you're eligible for this very generous insurance, which doesn't have any gatekeepers. Medicare doesn't have gatekeepers, unlike the insurance that we all have for right now. And so you just turn on healthcare. And so if you're somebody that's good at it or living in a place where everybody's good at it, you're going to turn on a lot of healthcare. And highly educated white people are really good at that. Okay. So that's been the design-based approach. What's going on the other side? Well, one important thing I mentioned before is that on the sort of conflict or growing tension between these different approaches. On the macro side of the profession, which is still a major chunk of all faculty, the DSGE model becomes the working model. So these, if you write down a model that has, or state a narrative framework that has no dynamics, full information, and partial equilibrium, that just is so far removed from the working models that people are working with every day in macro, that it seems like why would that even be interesting or lead to the right answer? Second thing that's gone on is a lot more empirical work in I.O. In the 80s, there was very little empirical work in I.O. In the 90s, it started to make a resurgence, largely influenced by students of Dan McFadden, including Ariel Pecos, who were very influenced by this logit framework where you're going to write down a complete DGP. You're going to write down how the X's matter and how the unobservables matter, and you're going to specify that completely so that you can do out-of-sample forecasting. Or you can do modeling of the share of bids and outcomes in auction models. And these are deeply structural models because they're kind of asked to be used in a way that's going to be pretty far out of sample. You know, if you think about what do you observe in an auction model, you at best observe 5 bids and somebody wins. And from that you're supposed to infer quite a bit of information. Sort of 6 numbers in a 6-person auction, and you're going to try and infer a lot out of that. And so you need a lot of structure to do that. There's been some new developments in econometrics, so the mixed logit, which extends McFadden to a richer framework. John Rust figured out how to take a multinomial logit and or nested logit and make it into an intertemporal problem. So Rust's famous papers really are extensions of the logit, building the fact that you can take the inclusive value from a nested logit and turn that into an Emacs for a dynamic programming problem. We've got a lot of progress in approximating methods for solving dynamic programming problems. There's been a lot of advances in simulation and integration techniques, and there's been some new understanding in partial identification, so we're a lot further along in econometrics. So, what are the areas of disagreement in the structural and reduced form, or I call it model-based and design-based approaches? I would say number one probably is what's a good enough model? Okay, is your model complete, complex enough to really be representative and interesting or not? Design-based papers are often using very simple models, no formal derivation of the DGP. The emphasis is on these predictions and falsification. The structural papers are going to follow the McFadden idea. They're going to derive a DGP, write down a DGP. They're going to emphasize sophisticated agents, equilibrium behavior, and so on. So this is, kind of almost philosophically different view of the world. Another related question, yeah.
What's DGP?
Data generating process?
Right.
Sorry, so that's like the stochastic parts of the model. Yeah, sorry. What are the parameters of interest? So if you hear somebody say, what are your parameters of interest, that's usually implicitly going to, a criticism is coming very soon. What they really mean is, you've estimated some model and you've got these regression coefficients. Why are those regression coefficients of any interest to me? What can I do with them? Okay? So if you think about it, in a design-based approach, you're estimating some regression. You estimate y equals x beta plus epsilon, which is always what you're going to do, and you talk about how beautiful beta is. It's extremely well identified. I've got the best beta of all time. The model-based approach says, look, there isn't such a, you can talk about that, but that projection doesn't mean anything. What we're really interested in is this model that says that there's some y's, there's some x's, there's some error terms, and there's some betas, and theta is what those are the parameters of interest, theta. Sometimes you can estimate those by using simulation-type techniques, but there's a big debate, which is more useful. This is sort of one way of thinking of the Lucas critique. The Lucas critique says, beta's no good because betas change as the inflation environment changes. But theta, which are the underlying parameters of the production function and the consumption function, they are the things of deep structural interest. Of course, if you think about it carefully, there's very few thetas that are really exogenous. And I give an example here. If you're trying to understand welfare take-up, why do people participate in welfare? Obviously, there's labor supply, there's stigma preferences and so on. Labor supply preference. But if you look at the data, you ultimately come away thinking, well, maybe some of those things are themselves endogenous. If you grow up in a community where everybody participates in welfare, maybe there's less stigma. Maybe you realize how the system works. You grew up in Newfoundland, you know how the unemployment insurance system works. You know you work for 10 weeks and collect your unemployment benefits for 40. So those kind of things that appear to be deep structural parameters may themselves be exogenous. So I think you can take this argument of parameters of interest to a kind of any level of absurdity you want. So I don't know that's really a telling criticism of any kind of economic model, because at the end of the day we're going to have to say something. Identification. Design-based practitioners are really emphasizing that. The model-based practitioners are often doing something much closer to calibration. They're saying, I've got a few parameters that I can nail down from exogenous sources, like interest rate, degree of risk aversion. I might bring them in from some other study, and I've got some other information, labor share, other kind of characteristics. At the end of the day, there's only a couple of parameters I need to know, and I'm going to use that information to try and show how my model describes reality. So it's kind of a very different approach. There's not really a sense in which a lot of model-based studies are really estimating parameters fully. They're more showing that a model can describe reality and that you can then use it to illustrate what would happen in an alternative reality that doesn't currently exist, like an antitrust environment, for example. We're trying to say, should I allow merger to go through? Yeah.
When I was in graduate school in the late 80s, early 90s, there was calibration being used by development economists. It was completely laughed at by everyone else, especially macroeconomists.
Yes, now they're
and I don't understand how suddenly these, the Chicago macroeconomists who say they're so serious about econometrics and so on, they suddenly doing everything in calibration.
Right.
How does that happen?
Well, a fundamental rule, I think, in economic, I don't know other scientific fields or intellectual fields, but a fundamental rule is things go in and out of style. Whatever used to be good soon will be bad, and vice versa. And so I think it's partially that. I think it's partially the style of development economics that was done in the 70s and 80s is very close to what Deron's model was arguing we need to do again. Yes, so it's come back. That's a grander style. We're trying to simulate models, and that's kind of what they're doing in that one. Yeah. So development economists were ahead of the curve, I guess you should say. Here's something I think is really important to understand, is how much inherent confidence do you have in your working model? A lot of times people that are doing model-based work really believe their model. So if you think of macroeconomists, neoclassical macroeconomists, they really believe a large chunk of that model is correct. It's just a matter of nailing down some other part. Labor economists tend to believe nothing. We're the home of the null hypothesis. Zero is good. So we tend not to think that I think we're maybe too extreme, but I personally am like this. I don't believe anything. I think, okay, it's possible people behave like that. I'm not entirely sure if we showed that people behave like a certain way today, that 5 years from now or 10 years from now they'll behave that way again. I think that a lot of social behavior is moving. So I have much less confidence in any working model. I think it's interesting, but I'm not sure that even if you can show me that your model works really well today, that I would necessarily think it's a good basis for forecasting the future. For example, if we're thinking about immigration research, I can use the data from some country and study the effect of some aspect of immigration. Does that apply to other countries? Does that apply to other waves of immigration? I'm not entirely sure. I think there's a lot of subtle elements there. So a lot of this is sort of how willing are you to say, okay, this is the right model, I'm going with it, and I'm going to use it to estimate the parameters and do some welfare analysis. That's what I need to do in the field right now that I think are important. What is the rise of experiments and the backlash against that? So we had the rise of experiments, that's already true. Now we've got the backlash. I'm going to talk a little bit about behavioral economics and the limits of what I call uber rationality, which I think is an important trend. And then I'm going to talk about normative versus positive, which I think is also important. Okay, the rise of experiments. There's no question experiments are far, far more important in the field than they were. Stefano Ulrich and I did a paper in the JEP a while back, and we classified all the papers in the top journals. We found in 2010, 10% of papers in the top 5 journals are lab experiments, and actually in the AER is 20%. So if you wanted to get a paper in the AER in 2010, lab experiments seemed like a good way to go. Field experiments are a much smaller fraction of the top 5 journals, but they're pretty important in the next level field journals. The AEJ Applied, Esther Duflo has kind of made that into a field experiments journal. I'm on the editorial board. I've published a few papers there myself, but I'm not criticizing. I'm saying that that's one of her goals, is to try and publish field experiments. A lot of other papers that are not experiments, most people think they are. So this is a classic, the Bandiera, Baranski, and Brazil. These are the fruit pickers these are papers about fruit pickers in England. And they're talking about the different incentives that are offered to managers of these companies. And everybody thinks of those as experiments. Actually, they're not. What happened was the company just changed from one policy to another, and they studied before and after. So it's a pre-post design, no control group. Roschetti, Looney, and Croft have a paper similar to that. They're studying what happens if you put the posted price includes the sales tax or doesn't include the sales tax. They did a quote-unquote experiment at Safeway. It's not an experiment in the sense there's no control group. There's just a pre-post. It's almost as good as an experiment in some contexts. It depends on whether you're Paul Holland or not, whether this is an experiment. So things that are close to experiments are also, if you put them in here, there's way more papers that are like that. The backlash, we're familiar with this, I think. Heckman and Smith were early on this topic, saying that there's a lot of problems with experiments. Angus has a pretty well-known paper, and then you've seen the reaction to Esther and Abhijit's book in the recent JEP. There's 2 review articles, both fairly critical, saying that they're kind of saying we need to have more field experiments in development economics, and those 2 review articles, one by Mark Rosenzweig and the other by Martin Revellion, are saying not really. So what's going on, one thing they do is they emphasize the limitations of randomized field experiments. So there's often flaws in design, there's incomplete compliance and so on. There's often a problem with generalizability. A good example of this in the labor supply area, there's a paper in the AER which studies bike messengers. Well, first of all, everybody knows bike messengers are all meth addicts, but at least in San Francisco. So I'm not sure I want to generalize anything from bike messengers. This paper does show that if you change the kind of marginal incentive to bike messengers for 1 week versus another week, they bike harder. Now, what does that say about labor supply reactions to business cycle frequency fluctuations? It's really hard to tell, right? Because actually, in the labor supply studies, we're often assuming that all the hours in a year are perfect substitutes. and the impervy substitutes with the hours in another year. So that, aggregating from a weekly behavior of bike messengers to the annual behavior is very, very hard. So I think that's not very easy to generalize. There's a lack of theoretical foundations, undeterminable reduced form, and the distribution of treatment effects. So that's kind of the litany of criticisms that people make. And since I'm almost out of time, I'm just going to assume that everybody knows the litany. You can use it if you need to, or you can be prepared to have your defense against that. I think the bigger question is this. It's really the question of, there's a set of questions you can answer with an experiment, and there's a set of questions that you can't. I would never rule out that somebody couldn't come up with a clever way of doing something that's pretty close to an interesting experiment on some institution. I think we shouldn't rule out human creativity. I mean, because when I saw that charitable giving paper, I thought, boy, that's brilliant. I wouldn't have thought of that. Now, everybody's talked about the warm glow theory of giving and all that stuff, and these guys came up with a pretty good test of that. So I think it's possible. We shouldn't rule out that somebody can come up with experimental tests, but ultimately, the big question is, what should we be trying to learn as economists? And if you think that what we should be doing in economics is studying how we teach poor kids in India, or how we organize classrooms in San Diego, why do we have to learn Slutsky symmetry in the micro core? And why do we have to learn DSG modeling in the macro core? And why do we have to learn kernel density estimation in econometrics? If this is what we're going to do, shouldn't we be training the graduate students on things like pedagogy, or on how schools are really organized, or how I do research on hospitals, how hospitals really run, right? In other words, should we be more like sociology, where if you're going to work in health, sociology of health, you're kind of expected to have spent 2 years as an observer in the emergency department. And we don't really expect that of economists. Maybe if that's the kind of work, we're going to do this style of work, maybe we should do more of that. And I think there's an argument for that. And actually that's the trend in development economics, the field work. You're not allowed to comment on the country until you've spent at least 15 minutes in the airport. Is that right? Yeah. I got that from my old friend Mark Tercidis, who never left the airport. So, okay. Another thing that I think an interesting trend is how behavioral economics fits into this. Now, I'm particularly influenced by that because many of my colleagues are behavioral economists, and it's kind of it's either a new trend or a disease, depending on whether you're inside Berkeley or outside. I want to argue that actually there's been a long-standing tendency for economists to fight against uber rationality. So when we were children, and when I was a child, I learned about the Lester-Maclop debate. This was in the textbooks in the 70s. And that was supposed to show how apparently Maclop, who was, both of these guys were professors at Princeton. Maclop was dead by the time I got here. Dick Lester was a friend of mine, so you can sort of tell whose side I'm on here. But Maclop said, well, you can't really understand how people behave because people can go out and pass a car or shoot a pool cue and they don't know physics. So just because somebody doesn't really know what their cells are doing and can't explain it in scientific language doesn't mean that the scientific model isn't correct for what they're doing. And there's something to that. Dick Lester, on the other hand, was trying to say, well, look, when you do the empirical work and you raise minimum wages, employment doesn't fall. So there was kind of a misstatement in that literature. Herb Simon, in the 50s, had a pretty elaborate set of theories, won the Nobel Prize, actually, for saying that firms don't really maximize profits, they're doing something else. And so he was kind of an early version of this. Bob Solow, when the early versions of Rational Expectations came out, kind of strongly put himself into a corner of saying, look, I'm not against rational expectations. In fact, Solow was a great theorist, probably one of the best of the 20th century, a great model builder. But he thought that was gone too far. That just didn't make sense. That was too much rationality. And in the recent debate, in the recent decade, we've got a lot of Kahneman and Tversky-style research. If you read Danny Kahneman's new book, it's really entertaining kind of description of some of these issues. I think it illustrates very well that one perspective, even though he's not an economist. We're sort of more and more attention to things like defaults and reference points. We're trying to understand who contributes what to their pension system. Would we be better off knowing like the neoclassical things or what the default was of their pension? Well, actually the default. So as an empirical matter, I think as economists we have to admit that these things matter. It's too bad for our uber rational models that it's important. inattention and other cognitive failures. If you look at people's choices for what pharma plan, what plan to be in Part D of Medicare, that's the part that your parents or grandparents are vigorously worrying about every October, which one of these plans, and it turns out that like 85% of people, 85 or 90% of people are in the wrong plan. They're actually spending more on the plan they're in than in some alternative plan that's out there. The plans are incredibly complicated. It's very hard to forecast where you are. It's cognitively demanding, and we're asking 85-year-old little ladies in Florida to make this choice. And then there's decision theory. Decision theory is my favorite because that's uber rational, but it says actually people don't have von Neumann Morgenstern preferences, let alone separable preferences between states and time, which you kind of need for a DSGE model. So if you take, there's nothing in economics that says that people have to have von Neumann Morgenstern preferences, or that have to have separable preferences. And once you go down the decision theory route, virtually any kind of choice model, it gets wide open. It's very interesting to think about how people make the decisions they make. And this sort of deep inside of microtheory part of research is sort of undermining, I think, in some sense, the uber-rationality side. Okay. So state-of-the-art models that are used in a lot of the most sophisticated are often really simple. Linear preferences, 95% discount rates. I think it's an interesting question whether we want to have at least some people in their research testing the constraints that other people, or assumptions that other people are putting into their models. So some classic modelers are out there building models of education decision-making, occupational choice, where everybody's forward-looking, no credit constraints. I think it's really interesting for someone else to say, well, let's look at something else. Let's look and see, I've got a program here, some kind of quasi-random assignment or regression discontinuity, access to loan. Does that make a difference? If it does, that kind of says there's something else going on besides what's going on in the uber-rational model. I think that ultimately we're going to have to admit the fact that in the model, in the world as a whole, there's a wide variety of agents. So it's not just James Bond. We've got, who was the other guys who was always against? The ones who kind of have James Bond right there for 20 minutes and could have shot him any time in that 20 minutes, but he still manages to get away. So they're the naive agents. They didn't see the previous shows. And I think institutions might evolve. You could imagine a nice scenario where institutions evolve to support sophisticated decision making. You could imagine another scenario where Medicaid Part B evolves to maximize the profits of the insurance companies by taking advantage of cognitive failures. And then finally, this is my last slide, second last slide, normative and positive. This is something that I've noticed a lot in the last couple of years and I've been thinking about a lot. I've never written a paper that has welfare analysis in it. I've always been very uncomfortable about that. I've often felt, my personal view is that if we knew enough to be confident about the positive side of what we're talking about, we could let somebody else do the normative side. But there's a huge number of economics papers coming out now which have welfare analysis. And on the job market, the perception of grad students is they've got to have a welfare analysis in their paper. So there seems to be an increasing demand for normative questions. And a model-based approach, you need a model to do welfare analysis. So you need a fairly well-specified model with a lot of confidence in that model to do a model-based analysis. And some of these design-based approaches are really building on opportunistic designs are often just not going to deliver. So if your goal is to say, I want to reform the unemployment insurance system and I need to know, should we raise the replacement rate? First, you're not a labor economist. The labor economists would never say that. But you're going to need to have models. So, final thoughts. My view, economics is fundamentally different than physics. I was a physics undergraduate. I kind of got far enough in physics to know what standard model vaguely is. And the standard model, there's no standard model in micro. We are so far away from having a standard model. And so many of the premises in even our best specified models are incorrect. There's non-separabilities, there's all kinds of inconsistencies. I gave an example, speaking to someone earlier today. If you could probably sell insurance in Las Vegas against betting losses. I bet you could make money doing that. So there's a lot of things that we're kind of building into our models that are wrong for some fraction of agents. And we just have to recognize that. We don't have like passive particles where every particle is going to behave the same, at least statistically. And so I think there's a need for many different kinds of applied work. The test the model kind, that's more a design-based. Fit the best available model, that's more model-based. And then finally, I haven't really talked about this, but I think there's also a lot of room for what I would call descriptive work, where you're trying to build the facts together to make the argument that maybe that we need a new model, or maybe an old model really does work well. This is sort of a part of research that I think is underappreciated, but also quite valuable. So I'm kind of a believer that all strands of work are equally valuable, and I'm glad to see all kinds, but I think that it's helpful when you're writing a paper, think about it, to understand a little bit more where you fit into that spectrum with your current paper. Anyway, I'll take some questions if you want.
Questions?